There are these unseen heroes of mega construction. They operate high above the ground, building some of the world's most ambitious projects. So today, we're going to look at the machines that can go where literally nothing else can. The giant, gravity-defying cable cranes.
So picture this. Really think about the challenge here. You've got to build a massive dam in some remote mountain gorge, or maybe a bridge stretching over a raging river. The thing is, there are no roads, there's no flat ground for your heavy machinery. So, how on earth do you get tons and tons of concrete and steel exactly where they need to go?
Well, the answer is this incredible piece of engineering that, solves this epic problem with just surprising elegance. It's called the cable crane. And really, it's basically a construction site in the sky.
Okay, the core concept here is actually surprisingly simple. At its heart, a cable crane is pretty much just a giant, super strong zip line. But, it's not for people. It's built to carry massive loads of construction materials with absolute pinpoint accuracy. So, if we're going to get a little more formal about it, it's really a kind of hybrid system. It combines the horizontal movement of, say, a ropeway, like a ski lift, with the vertical lift of a crane. And what this does is it allows it to cover a massive area, both horizontally and vertically, all without ever touching the ground. Pretty cool, right? So you might be wondering, okay, how is this different from those tower cranes we see all over cities? Well, a tower crane is ground-based, right? It has a pretty limited circular reach. A cable crane, on the other hand, is suspended. It's capable of spanning entire valleys, giving engineers access to places that are completely, totally unreachable otherwise.
Okay. So it looks super impressive, no doubt about it. But how does this thing actually work? Let's get into the nitty-gritty, the mechanics behind this sky-high workhorse.
All right, these are the essential parts of the whole shebang. You've got the main track rope. Think of it like the highway in the sky. Then there's a trolley that travels along it and a hoist rope that does the actual lifting. But the real muscle, that comes from the powerful drive station and the absolutely massive anchoring system that holds it all together under just immense tension.
And here's how it all comes together. It's a pretty brilliant sequence. First, those massive cables are stretched tight and tensioned. Then, a load, let's say a giant bucket of concrete, gets attached. The trolley then zips it horizontally across the gorge, and the hoist rope lowers it with incredible precision right into place. It's like a beautifully coordinated dance of giant machinery.
Okay, so that's the theory behind it. But now, let's talk about the real-world impact. Because trust me, the structures these cranes build are nothing short of monumental.
You'll find these things on the absolute toughest jobs out there. They're pretty much indispensable for building dams and hydropower plants, for spanning huge gorges to build bridges. They even use them in forestry to carefully move logs without having to build all these damaging access roads.
Yeah, and a quote from our source material really hits the nail on the head here. In the world's most extreme environments, we're talking places like the Himalayas, where conventional construction is just flat out impossible, the cable crane isn't just an option. A lot of the time, it's the only option.
So, to give you a real sense of the scale we're talking about, let's look at a case study, the Tehri Dam project in India. This was a colossal undertaking in a super challenging mountain region, and you guessed it, the cable cranes were the absolute stars of the show.
The scale here is just staggering. The main cables for these cranes stretched a full kilometer. That's 1,000 meters, over 3,200 feet, from one side of the site to the other. Just think about that for a second. Simply installing and tensioning a wire that long and strong enough to support immense weight is an incredible feat of engineering all by itself. And look, it wasn't just about distance, it was about pure power. A single trip could carry over 20 metric tons of material. To put that into perspective for you, that's like the weight of 3, maybe 4 adult elephants just suspended from a wire, being flown a kilometer across a remote mountain valley. Just wild.
Okay, so clearly this is an incredibly powerful tool. But, like any specialized piece of equipment, it's not perfect. It has its own set of strengths and weaknesses. So let's weigh them up. All right, on the plus side, the advantages are pretty clear. They can conquer the most difficult terrain, they have an enormous reach, and a huge lifting capacity. They can even be more eco-friendly, which is a big one, because they get rid of the need to build all these damaging access roads. But the trade-offs are significant. You're looking at a very high setup cost, a really time-consuming and complex installation process, and they can be pretty sensitive to high winds.
So, what's the bottom line here?
The crucial point is this. A cable crane isn't for your everyday project. No way. It's the specialist you call in when the job looks absolutely impossible. Think of it like a surgical instrument for mega construction, designed to turn these insurmountable obstacles into the foundations for incredible progress.
And all this leaves us with one final thought. The cable crane was, without a doubt, an ingenious solution for the big challenges of its time. But as our ambition to build gets even bigger, as we aim for even more extreme and ambitious locations, you gotta wonder, what kind of giant, skybound builders will the next generation of engineers dream up? What do you think?